Good evening and once again welcome to my YouTube channel, Pearson and Excel International Maths by Mr. Kamoto. And we continue to explain Pure Mathematics 1, International Advanced Level, and we are in topic number 8, and we will be discussing something on page 157, and this is what we shall be calling differentiating function that is x raised to power n. And this is nothing new. We understood this in year 11 in our IGCSE course. And of course, under 8.3 on page 157, we remind ourselves what we understood then. You can use the differentiation of you can use the definition of the derivative to find an expression for the derivative of x raised to power n, where n is any number. And of course, this is called differentiation. The definition of the derivative is what we call differentiation. We differentiate with respect to something. And for all real values of n, and for example, for all real values of n, for all real values of n, you may have if there is a function of x which is x raised to power n, we should know that the derivative of the function f prime x, this is the same as saying dy dx, is going to be the power multiplies out n x n minus 1. And it's the same thing if y is equals to x raised to power n, because most of you may not be familiar with the function of x. It's the same thing. The function of x means simply y. Then dy dx is n x n minus 1. It's one of the same thing. And if y is equals to axn, then dy dx is an xn minus 1. It's just one of the same thing. So it doesn't matter whether we have y is equals to anything or fx is equals to anything. It simply means one of the same thing. And I want us to directly go to example number 4. Example 4, as you use this kind of understanding. Find the derivative, find the derivative of x when fx is equals to, let's talk about part A, x raised to power 6. Now, if this is the case, then the derivative of fx or the dy dx, assuming this is supposed to be fx or y is equals to, for example, we should have talked about fx is equals to x6 or y is equals to x6. It's one of the same thing. Dy dx or the f prime x is given by the index becomes coefficient 6x, and then the index reduces by 1, which is 6x5. And part B, y is equals to x raised to power a half. Then we are going to talk about dy dx is supposed to be a half x raised to power minus a half. And let me explain something here. Why minus a half? Because the new power reduces by 1, and the original power was a half. A half minus 1 is obviously negative a half. And because we have learned the laws of indices, it is not final to write a variable with a power that is having a negative sign. So we would want to write it in the simplest form, 1 over 2 root x. Why root x? Because it would have been 1 over 2 x raised to power positive a half when it is now at the denominator position. But any number raised to power a half is obviously root that number. That goes without saying. Part C, it's important to note that x, or let me start with y is equals to x raised to power minus 2. And now dy dx is minus 2x minus 3. And this one is supposed to be finalized in terms of minus 2 is a constant, x raised to power minus 3 goes to the denominator position, and of course it changes the sign. So that is the final submission. Let's look at part D. Let's look at part D. Let's just look at part D, and part D talks of the function of x is x squared times x cubed. First of all, we have to apply the laws of indices here because this is the same base and multiplied out. So we have x is for 2 plus 3, which is x5. And it goes without saying the derivative of that function is 5x raised to power 4. And that is what we have as far as that part is concerned. Further looking down there, part E, y is equals to x over x5. And again, we need to apply the laws of indices here. There is x to power 1 here silently, and there is x to power 5 here. So this is the same as x power 1 divided by x power 5, which is x power 1 minus 5. And of course, this is x raised to power minus 4. If that is true, then the derivative, which is dy dx, at that point the dy dx becomes, the power becomes a coefficient minus 4x. Of course, the power reduces by 1. Minus 4 minus 1 becomes minus 5. And at the end of the day, we have minus 4 all over x raised to power 5. And that is what we have as the final submission. So please note the natural law of differentiation. When when we have y is equals to x raised to power n, then dy dx is n x raised to power n minus 1. And this is not new, and that is exactly what we need to form as basis of primary differentiation. All right.